Hey, come on, always look for greatest common factor first. I know that didn't go in. I'm embarrassed, but I'm not going to record this video again just because I missed. Sometimes we fail. The key is to get back up again. See, I made that one. Sometimes you miss, sometimes you make. We're talking special cases today. The difference of two squares, difference means subtraction. Two squares are perfect squares, so things that you can square root. So when you have a perfect square minus a perfect square, that's going to factor to a plus b times a minus b. They're the same thing, except one has a plus, one has a minus. You just square root each of those terms. You'll see in a minute. We also have these perfect square trinomials. So if you were given a minus b squared and you FOILed it out, it would work to the first term squared minus 2 times the product of a and b plus b squared. So we're going to have to go backwards with that today. If it was a plus b squared, the only difference is it would be plus 2ab. We'll see. Let's try this out. Okay, there we go. X squared minus 9. There's just two terms there that we can square root. So all we have to do is square root each one of them, put one with a plus and one with a minus. X plus 3 and x minus 3. That's our answer, if it shows up soon. Oh, we'll just hang out until it is. It's magic, unlike Dr. Strange over here. So that's our final answer. Now, if you're like, oh, what? If we FOIL this out, what's x times x? X squared. X times negative 3 is negative 3x. 3 times x is positive 3x. Woo! And then 3 times negative 3 would be negative 9. So the negative 3x and the positive 3x, they will cancel each other out. So all we're left with is x squared minus 9, which was the original problem. So it does work out. I'm not absolutely bananas, guys. Now, it has to be the difference of squares. Number 2, I'm trying to throw a curveball at you right away. But you're too smart for that. It's difference of squares. There's no such thing as the sum of squares. So you can't make this x plus 5 times x minus 5. It doesn't work. So this one is not factorable. I don't know what's going on with the delay here. I just don't even know, you know? I'm like, who knows? 2r to the third minus 8r, I can't square root either one of those. But what does Mr. Plant tell us every time? Look for the greatest common factor first. So 2r to the third and 8r have 2r in common, which would leave us with r squared minus 4. Now, r squared is a perfect square, 4 is a perfect square, so, and we have a difference, the subtraction in the middle. So we'll keep our 2r out there. Square root of r squared is r, square root of 4 is 2. So r plus 2 and r minus 2. Oops, started writing a 2. Who knows when that'll show up? There we go. Oh, goodness. That'll probably show up eventually. There we go. Boxing it in. It's magic. Magic is all around us. You guys know the song. Come on. How come no one's singing with me? 16t squared minus 9. Do they have anything in common? No. Can you square root both of them? Yeah. Square root of 16t squared is 4t. And no, I didn't say 40. Square root of 9 is 3, so we have 4t plus 3 and 4t minus 3. And again, the order doesn't matter. You can switch the parentheses, have the minus first, the plus second, and it all works out. 18x minus 2, 18x squared. They're not perfect squares, but they do have a common factor of 2. So if we factor out 2, we'd have 9x squared minus 1. Oh, and those are two things we can square root. The square root of 9x squared would be 3x. Square root of 1 is 1, so 3x plus 1, 3x minus 1. Okay, there we go. I don't even have time to box it in. I don't even have time. I have time. For you guys, I have time. I'm just sweeping. Okay, 4x squared, 20x, 25. What? There's no common factor. You could totally do the 4 times 25, get 100, figure out what factors of 100 add up to 20, which would be 10 and 10, and then break it down with the 4. That all works. But if you recognize that you can square root the first term and square root the last term, there's a good chance it's one of these perfect square trinomials. So what is the square root of 4x squared? 2x. What's the square root of 25? 5. Now, the symbol that goes in the middle would just be the first symbol, because the last one is always positive. Because if it was positive times positive, positive. Negative times negative, positive. So you have to look at that first symbol. So double check, because the middle term needs to be, if you multiply these two terms together and multiply by 2. So 2x times negative 5 is negative 10, times 2 would be negative 20x. So that would be our final answer, which you would get there eventually if you did it the old way. All right, I think I've got 7,000 more for us to try out. M squared minus 225. Let me show you something else you could do in case you forget difference of squares. You could always make this m squared plus 0m minus 225. And then you're like, well, what factors of 225 are 0 apart from each other? Sure, if that helps you, go with it. But if you have two terms that you can square root and there's a minus, then it's a difference of squares. Square root of m squared is m. Square root of 225 is 15. It's 15 times 15. So m plus 15 times m minus 15. Over yonder, I have 3 terms. So when it's 3 terms, it's going to be one of those perfect square things. Is there a common factor? No. Square root of 100v squared would be 10v. Square root of 121 is 11. Let's double check. If I multiply these together, I get negative 110v. And then if I multiply by 2, I get negative 220v. Which, if you wanted to FOIL this out, you could just write 10v minus 11 times 10v minus 11. You can FOIL it, and I promise it works out to 100v squared minus 220v plus 121. I promise. Okay. 25r squared minus 144g squared. Do they have anything in common? No. Can I square root both of them? Yes. Is there a minus in between? You know it. So, square root of 25r squared, 5r. Square root of 144g squared would be 12g. So 5r plus 12g times 5r minus 12g. Uh-oh. We're in our room here, folks. Gather around, folks. So now they should go pretty quick for us. 25q squared minus 12. Do they have anything in common? No. Is 25q squared a perfect square? Yeah, it's 5q. Is 12 a perfect square? No, it's not. So this is not factorable. Yes. 49y squared minus 4. Common factor? No. Can I square root them both? Yes. Do they have a minus in the middle? Yes. Square root of 49y squared is 7y. Square root of 4 is 2. So 7y plus 2 times 7y minus 2. 9c squared plus 64. Common factor? No. Do they have subtraction in the middle? No. So we can't do this. because there's no such thing as the sum of squares. So not factorable. I know you were sad about that one because you were all excited. You're like, 3C, 8. But if that was minus, we could have done it. But alas, it was plus. Oh dear. 3x squared, that's not a perfect square. 48 is not perfect. 192, none of that's perfect. But do they have a common factor? Yes. We can factor out 3, which would leave us with x squared plus 16x plus 64. Now, is the first term a perfect square? Yes. Is the last term a perfect square? Yes. So we'll have our 3 on the outside. Square root of x squared is x. Square root of 64 is 8. And then the middle would be our first symbol. So x plus 8 squared. Double check. If I multiply these two together, x times 8, and then multiply by 2, do I get 16x? Hey, all right. We did it. 6r to the third, 150r. Do they have a common factor? Yeah, they do. 6 goes into both of those, and they both have an r. So 6r times r squared, and 6r times negative 25. Do we have perfect squares? Yeah. Square root of r squared is r. Square root of 25 is 5. And there's subtraction in the middle, so we can do the difference of squares. R plus 5 is r minus 5. Don't forget the greatest common factor that you factored out already. Suppose a classmate factored the binomial at the right. What error did your classmate make? This is typical. I was going to make up a fake name, but now I'm scared that it'll be a real name of a student, so I won't. Quarvath, our friend Quarvath, he saw 4x squared minus 121, and he was like, great. The square root of 4x squared is 4x. Square root of 121 is 11. Okay, they have the minus 11, right? They didn't take the square root of 4x squared. Take the square root of 4x squared, which we'll write in parentheses. We won't write it in parentheses, but it would be 2x. The other problem is this is a difference of squares. So it should properly factor to 2x plus 11 and 2x minus 11. That's it for the notes, man. We got to practice this stuff. Let's practice away. Okay.